Everyone, today I will be presenting our recent work PhysTwin, physics-informed reconstruction and simulation of deformable objects from videos. This project is led by Han Xiao under the guidance of Shenlong and Yunzhu. Our goal is to create physical digital twins of various deformable objects, as demonstrated above. Given RGBD observations of a human-object interaction video, we construct the physical digital twin that captures geometry, dynamics, and appearance. With the constructed PhysTwin, we can predict the next state of a deformable object under novel actions. Using both the original and new actions, we achieve accurate tracking and high-quality rendering results. Here we present examples where our rendered results are overlaid on the original observation videos. PhysTwin demonstrates strong performance across various scenarios, including stuffed animals, ropes, clothing, and packages. To build PhysTwin, we leverage the spring mass model as a physics prior and optimize the object's geometry, topology, physical parameters, and appearance using chamfer tracking and rendering laws. This optimization framework enables the effective and efficient construction of PhysTwin. With the constructed PhysTwin and our real-time simulator implemented in Warp, we enable real-time interaction via keyboard input. The deformable objects respond with realistic and physically plausible motions. Here are additional examples showcasing various types of deformable objects, different numbers of hands, and a range of motion patterns. Our real-time PhysTwin also supports interactive teleoperation. In this example, a student uses Gallo to teleoperate the robot arm folding a piece of fabric. On the screen, we display a real-time overlay of the PhysTwin. The results demonstrate that PhysTwin closely aligns with the real-time observations and is capable of accurate real-time future state prediction. With the accurate dynamics provided by PhysTwin, we can integrate traditional model-based planning methods to tackle target-driven manipulation tasks. Here we demonstrate guiding a rope into an S-shape configuration. We also demonstrate planning results on a more challenging close folding task. These results highlight the potential of PhysTwin for enabling advanced robotic manipulation. Thank you for listening.